It's great to be here and seeing this energetic audience in this session. At first, let us introduce ourselves. My name is Bingi Narasimha Karthik, and along with me, my colleague Ramkumar Nagaraj. At first, I had around 9 years of total IT experience, in which 6 years experience in Adobe. Next, I will hand it over to Ram to introduce himself.
Hi, good evening all. So myself Ramkumar Nagaraj, as my colleague mentioned, so I do have around 20 years of work experience and I'm working for Adobe. I've been with Adobe for past 5.5 years. So with that, yeah, we are very much proud to declare that we both are kind of cubestroners. We both are from the same team, and as a duo, we have done around nearly 18 plus certifications. With that learning path, so my colleague will explain about what kind of problems we are facing in our ecosystem and how this learning has enriched us to fix that particular problem statement.
Yeah, thank you, Ram. Before moving to the further on problem statement, let us step back further and understand on multi-tenancy. Could I know if anyone is using multi-tenant Kubernetes clusters in your organization? Could you please raise your hands? Okay, I can see few. For others' interest, we could tell there are two types of multi-tenancy. One is soft multi-tenancy, other is hard multi-tenancy. Soft multi-tenancy is nothing but it's like living in a PG where in a single room there will be different sub-rooms. That is with soft multi-tenancy. But with hard multi-tenancy, you can think it of like an apartment building where there will be multiple rooms in single big building. So in both aspects, there would be a common foundation, right? That is nothing but, in this case, Kubernetes. So Kubernetes can enable both soft multi-tenancy and hard multi-tenancy together. So in Kubernetes, with soft multi-tenancy, we can have these kind of objects, like for example, ingresses, Kubernetes worker nodes, and also API servers also can be accessible by multiple tenants at the same time. With hard multi-tenancy, it's all separate cloud, separate cluster, and also separate environment. Environment would be the same, but it will be a separate environment. We won't be having any isolation with other other Kubernetes clusters. There is a limitation with soft multi-tenancy, right? Like for example, as it was listed, I can tell an example. Let's say you have a namespace where that pod is utilizing or requesting 1 GB of memory, but limits as configured as 8 GB. Then on the same note, there could be another pod, like another tenant pod, where it is over-utilizing all the resources in that node. In that case, your workload will be affected, right? Because that same resource allocation has been given to the other pod. So that's the problem with soft multi-tenancy. With hard multi-tenancy, the main problem is high operation overhead. You need to talk with the tenants, and you have to do the cluster upgrades or any other operations so that their workloads won't be that much affected as much as possible during the upgrades time. That is the problem with hard multi-tenancy. That is with general Kubernetes level. With monitoring also, there are two types of approaches we have. One is soft monitoring approach, other is hard monitoring approach. Soft monitoring approach is nothing but you have a single Prometheus in admin namespace. That Prometheus can scrape or forward the metrics to your other tenants that is deployed on the same cluster. That is with soft monitoring approach. But with hard monitoring approach, right? What will happen is for each tenant that is deployed in your cluster, you need to deploy a Prometheus that will forward the same cluster level metrics to the tenant Prometheus. It's like doing an identical job over and over again on various tenant Prometheus. By doing this, you will be having a huge number of cost implications, and also you also need to take care of the upgrades as well with high monitoring, because you need to make sure all the upgrade components on hard monitoring approach is working as expected. With soft monitoring approach, the only disadvantage is it could be potential data leakage. Like there could be a use case where one tenant can see the metrics of other tenant if the proper RBAC is not been configured. So in this talk, we want to talk about soft monitoring approach. For soft monitoring approach, there is only a current solution, which is nothing but Prometheus Federation. Could I know if anyone is using Prometheus Federation or heard of Prometheus Federation before? Could you please anyone raise your hands? Okay, I can see few 5-10 people. Okay, what Prometheus Federation is? Prometheus Federation is an inbuilt feature in Prometheus. You can enable it by simply simply an HTTP endpoint, nothing but /federate. So with Prometheus Federation, you can, tenant Prometheus can scrape the metrics from admin Prometheus, what all the metrics they want. But there is a problem with that. Like for example, if you have a big Kubernetes cluster where there are 500 namespaces or millions of namespaces, in that case, the central Prometheus could be overloaded and could cause higher memory consumption, and you need to keep on increasing the memory, and you can't able to sustain that kind of breakdowns during production environments. So that is the problem, main problem with Prometheus Federation. Other thing is there could be duplicate metrics as well. What it means is, let's say you are running high available Prometheus in your Kubernetes cluster. In that case, there will be Prometheus replica label will be added for each Prometheus instance. So due to this, at tenant Prometheus level, you can see multiple labels also can be seen by using this Prometheus Federation feature. So that is other challenges that we are seeing it with current Prometheus Federation approach. Now we would like to talk about our solution is on multi-tenant observability, why it matters and why it is important. With multi-tenant observability, that our solution we talk about in few minutes, you can able to identify, let's say you have a GPUs running in your Kubernetes cluster, you can identify how much IDLC GPUs that is running in your Kubernetes cluster, and you can eliminate those which could decrease your cost by 50 to 60%. That is one thing. Other thing is, definitely it will be near to real-time insights. Definitely, you might aware that Prometheus is not for real-time monitoring, but it tries to give real-time data by configuring the scrape interval by like 5 seconds or 10 seconds or 15 seconds. So it will try to give as much as real-time possible as like New Relic is for real-time monitoring, but we are talking about Prometheus. So that is with real-time insights on Prometheus. Next, operations simplicity. With our solution, you can able to deploy within few minutes, and the multi-tenant proxy would be ready and up and running without any hassle issues. That is the main benefits that we are talking with our solution. Next, I would like to hand it over to my colleague Ram, where he will explain about Adobe Kubernetes cluster and how much big it is that we are managing at our administrator level, and also talk about the multi-tenant proxy solution. Yeah, over to you, Ram.
Cool. Thank you, Bingi. So, yeah, as we mentioned, like Adobe platform, right? So our platform is a kind of like an ethos platform, and we do have like utilizing different service providers like AWS and then Azure and then private data centers and all. And you can see over here, like we are running around nearly 450 plus clusters. So depends upon the stage and the different environments and production too. Okay, now with the clusters, how many nodes? We are running nearly around 0.15 million nodes are there. And again, what is the purpose? We are having so much services have been onboarded onto those particular clusters. So majority of the in-house application in our organization is running in our ethos platform. So now think about how gigantic is this and how we are going to solve the multi-tenant monitoring approach as my friend, colleague discussed so far. Okay, so can you just tell me if you want to introduce a new object in Kubernetes, is that CRD component correct? If any of you raise a hand, if you want to introduce a new component, how can we introduce it? Through CRD? Okay, so the same way. Here we are using a multi-tenant Prometheus proxy as a kind of like a CRD which has been deployed. And this will ensure that you can scrap the metrics from the infra level. Infra level, or like overall the cluster level. Okay, I am the tenant A and then tenant B, tenant C are there. They want to know the metrics of the global cluster level. So where you can configure at the tenant namespace level. At that case, we are having the metric access CRD part. So with the tenant, will be sending the request what kind of metrics he want to scrap from the global one. And second, okay, we receive the metrics. How can we process it? So we need some sort of like API layer, right? So our component is integrated along with the Nginx proxy. That will take care of the rate limiting and then the validation, as well as it will just apply the filters, because we don't want to allow multiple metrics should be scrapped from the global to bombard the request. And of course, we are using the same kind of like Nginx rate limiting in the sense that you can see the token bucket, why it is needed, right? So using the HTTP kind of directive in the Nginx, we can configure what kind of namespace you can utilize. And you can just segregate also. So what is that? Each and every tenant, you can limit the requests also, how much requests I want. So we don't want to give equal proportion for the dev or stage or production to scrap the metrics. So with that, you can rate the limit also. So for development, you can have the 10 requests, and for production, you can have the 20 requests, 30 requests, something like that. So that can be achievable through our solution. And second thing is like you can see like the sliding window. So if you are going with the fixed window format, right, it will just go with like last 10 seconds means it will, at the 11th second, it will calculate. Okay, I have already done with the 5 requests, so let me add up. So it will just bombard the request. To avoid that, we are going with the sliding window. So at any last 10 seconds, we can just encounter that, okay, those metrics are allowed. If it is more than that, it will just drop the request. So that kind of feasibility at the tenant namespace isolation can be tuned on this part. And how we can select the different namespaces based on the labels. So we will be using the labels. So this is a kind of one of the kind of a code snippet example you can see. As we mentioned, like CRD is a main component, so which will be deployed in the tenant namespace. Over here, you can see the namespace of the tenant, and we can just configure what are the metrics you want to scrap from the global infra metrics. That you can just declare over here. Once the team is sending the request with the specific namespace, I mean the metrics from the namespace, what Nginx proxy will do, as we mentioned, it will do the CRD validation, and then it will do the proxy processing, and then it will do the aggregation also from the different names. And it will just filter the metrics. We don't want to scrap all the metrics. So we can just give what are the metrics you want. You can just go ahead and then scrap, and then there is a kind of like optional component, like you can do remote rewrite. From infra metrics, you can just send the metrics to the target individual namespace metric, Prometheus. Okay, so while we are considering this solution, we have just evaluated along with the Cortex. So how many of them have ever heard about the Cortex? Okay, thank you. So glad to hear that. So over here you can see what is the main thing is like if you want to set up a Cortex, it's a kind of like a component architecture, like multi-components are being deployed to make the Cortex functionalities working as expected. And second thing, in our solution, you can see it's a kind of like a single deployment. So it's a kind of a single proxy which will be deployed on the clusters. And second thing you can see, we can ensure that storage approach for the Cortex holds good because it's having the longer retention period. But in terms of like our solution, it will be a kind of limited approach. So with that, like Cortex holds good for the stronger retention. And third thing is like Cortex supports the horizontal scaling. You can just keep on bump up the recursion limits, CPU and then memory of those resources. But in our solution, Prometheus multi-tenant proxy, it will support the vertical scaling. And coming to the focus, as usual, Cortex optimizes mainly for the scalability. Our solution is mainly focused on the to reduce the operational overhead and then increase the simplicity. So over here, you can see, as we mentioned, Cortex is having variable components, right? So setup time will take large when compared to Prometheus multi-tenant proxy as a single deployment. And it's again directly proportional, components are huge, 8+ services. In our case, it's a kind of like a single service. And similarly, operation cost also more. And long-term storage, Cortex holds good when compared to the Prometheus multi-tenant proxy. And you can see the maintenance cost. As more components are there, if you want to upgrade the individual components of the Cortex, it will eat up the time. In our case, it's a kind of like a rapid deployment. You can just fast approach. You can go ahead and then upgrade or update the particular component in the cluster. And you can see GPU optimization. Yeah, so we'll just cover. So how it is GPU optimization is very much specialized in our criteria, right? Our solution is a kind of like a foundation. So on top of that, you can just filter the GPU node-based related metrics at the metric access CRD. And you can just use the patterns to select. So which are the namespaces and which are the GPU nodes are being sitting idle. And then you can just, you can have the tenant isolation also with that approach. So it's a kind of straight away you can go ahead and then further enhance the solution rather going and then doing a lot of modification of the Cortex cloud. So coming here, this is how we are currently monitoring the GPU nodes in our environment. So we are utilizing the DCGM metrics. It will just try to emit the hardware data, and then it will be sending to the Prometheus time series database. And we do have the Prometheus multi-tenant proxy where we can just filter out, as we mentioned, what are the metrics you want from the global metrics, and then try to send it to the local tenant space namespace metric. And of course, how it is going to attribute the cost. Yeah, so we can identify we will show you the next kind of different queries. With that, you can identify the ideal GPU nodes, and then you can just go ahead and then take prompt action on those nodes to reduce the cost. Okay, this is how the sample DCGM metrics will be collected. So over here, you can see from the GPU hardware layer, right? So DCGM daemon will do the conversion of raw data from the hardware, GPU hardware, to the GPU-based data. And again, what our container stack will do, right? It will just convert the GPU raw data to the Prometheus time series based data format, which will get injected into the database, and then we can do the scrapping of the metrics. And here are the couple of metrics. You can see the critical metrics which we have configured to identify the GPU nodes utilization in terms of CPU, in terms of memory, in terms of kind of thermal temperatures and then power. Okay. So over here, you can see, now we have the metrics. So how can we ensure that we can save cost from the GPU nodes? So in this, you can see from the metrics, identify which are the ideal nodes or GPU nodes are there, and then go ahead and then take action on cleaning up the nodes. That is one way through the GPU utilization and then the memory utilization. And second thing is coming to network bandwidth. So here, the NVLink bandwidth is mainly about how you are ensuring that GPU nodes are sharing the loads and it's fast enough to complete the training. So if it is very well efficient to complete the training in time, right? So you are reducing the kind of operational cost, and then you are reducing the energy. So ensure that you are having higher data link bandwidth between the GPU nodes. Second thing is you can see the training variance. What does it mean? So as per the industry standard, it was mentioned we need to ensure that it should not cross beyond the 2.1%. So it means you are calculating, for example, if you are having 5 nodes, are we equally distributing the workloads across those 5 nodes? Rather, if only 2 to 3 nodes are overutilized and then remaining nodes are sitting idle, right? So we are unnecessarily wasting the cost. So we are identifying that particular ideal nodes, and then you can do. So ensure that workloads are evenly distributed across the nodes. So with that matrix, you can save the cost. And okay, now we talk about the resources. So how about the kind of like GPU node level? You can see any kind of critical errors like based on the XAD, right? So any hardware faults, take immediate action on the nodes. And second thing is, last thing is like a power throttling. It's nothing like not related to the CPU or memory. So if it is reaching the power cap, right? So it will obviously reduce a kind of like a performance, and then it's not able to share the load across the node. So these are the key metrics which we have configured, and then we are like showing you an example. From your use case, you can set your threshold and then ensure that you are able to reduce the cost of the GPU node utilization in your infrastructure. Okay, now we have gone through the theory part. Let us go through how it is going to work in the cluster level. I'm just handing over to colleague Bingi. Yeah.
Yeah, thank you, Ram, for explaining the Adobe Ethos Kubernetes ecosystem and the high-level overview on multi-tenant proxy solution. Now, before going to the demo, this is the demo setup that we are showing in our in next couple of minutes. So at first, we will deploy a GPU workloads, which has been already been deployed on our provisioner namespace. And DCGM will be collecting the data. Next, on the step 2, we will be deploying the monitoring stack. The monitoring stack is nothing but Prometheus and Grafana, where it could able to scrape the metrics of GPU. It won't scrape the metrics from GPU unless we do the step 3. So that's what the step 3 is about. It will enable the multi-tenancy CRT that my colleague has been talked about in last few minutes. Let me go back to the terminal. So this is the over provision, right, that I have discussed in demo setup. So currently we can see there are only GPU workloads has been deployed and there are no monitoring services deployed in this namespace. Let me step back, and I would like to show what are the Prometheus or how many Prometheus has been deployed in our cluster. I will be using this command. This command will show all the Prometheus that has been deployed in our cluster. Currently, we are running five different Prometheus, and each Prometheus is having 2 replicas for high availability. So in total, we are running around 10 Prometheus and other Prometheus as well. That is for custom metric scaling. Next, as we can see, all the Prometheus is using common label called this one, right? App kubernetes.io/name equals to Prometheus. So this is the same configuration that we have defined in our multi-tenant proxy level, so that it will scrape the metrics from this infra or core Prometheus. So this is the multi-tenant proxy configuration. We have 2 configurations. One is for main container, other is for Nginx. Okay, for this one we have decoded in human readable format. Let me open that. So this is the human readable format. As we can see in here, that we are only scraping the metrics which is matched with this one in monitoring namespace. This means that all the infra Prometheus will match this label, and it can ship the metrics to the Prometheus proxy, which is act as a intermediate layer. Next, going back to the over provisioner, right? Currently, we can see these are the parts. Next, I will deploy the monitoring stack. I can quickly show in the meantime. So these are the monitoring that I am defining. This is a Prometheus, simple Prometheus config that has been added. Then this is the Prometheus stateful set that also been added to that namespace. then the service to access, and we are using HTTP proxy in our Ethos Kubernetes cluster. HTTP proxy backed up by Capcom. It's like an Nginx proxy, but with additional features. We are using a customized version of Capcom in our Kubernetes cluster. And this Prometheus URL service can be accessed on this URL. Next, same thing we have deployed for Grafana as well. This is the ConfigMap, and this is the dashboard as well. So let me list the parts. Currently, you can see these are the parts. Grafana, okay, Grafana is in running right now. Let me access the URL of that Grafana on Prometheus. At first, let's go for Prometheus. This is the Prometheus that has been deployed on that namespace level, right? Currently, if I execute this type of query, what this query will do is it will list all the DCGM metrics at this namespace level. I should be using regular match. Currently, we can see empty result. I will tell you the reason why. It's because, let me execute another query of getting the cube state matrix. This also will be resulting empty result. This is the Grafana GPU dashboard. It will take a little bit of time to open it. Okay, in the meantime, let me deploy this resource. This is the metric access that we have talked a few minutes back, right? Which will enable multi-tenant proxy, and these are the metrics will be shipped to our tenant Prometheus, which is nothing but our provisional namespace. Apart from these GPU metrics, these are the metrics also been shipped to that tenant Prometheus. Let me open this dashboard again. Okay, it's working right now. Seems like I exposed the password. It's fine. So this is the GPU monitoring dashboard. Currently, we can see no data. I will need to get it working. To get it working, I will deploy this custom resource object. Let me apply it. So as soon as I have applied this one, it will ship the metrics to this Prometheus in our provisional namespace. Let me see if it is working fine. Sorry, it's a typo. Yeah, currently it has been deployed. Let me refresh this page. Yeah, currently you can see the metrics has been seen. All the DCGM metrics has been seen once I deployed that metric access custom resource. This is at DCGM layer. This is the cube related metrics, which is coming from cube state metrics. If I refresh the dashboard as well, you can see the dashboard before seeing no data. Now we can see the result. The GPU utilization currently seeing 0%. Why? Because as you might aware, our provisioner parts is only used for adding the capacity to the cluster, so that if tenants wants to have the GPUs, those nodes will be readily available. So, but that parts won't be doing anything at GPU nodes level. So that's the reason we are seeing currently 0 utilization. But if your GPU parts having any work being doing at node level, those data will be seen in here. Other than that, GPU temperature, power usage, all the statistics can be seen in here. Yeah. Now, getting back to this slide. On the whole, these are the key benefits that Prometheus multi-tenant proxy can offer. One is self-service by just deploying multi-tenancy custom resource definition object. All the Prometheus that is there at Prometheus infrastructure level can be able to deploy to your tenant Prometheus. and it's very simple to deploy. Within matter of few minutes, you can manage multi-tenant proxy. Then it's also useful for identify the idle GPUs, which could reduce costs more to your organization. Yeah, that was it from my side. These are our contacts. Feel free to reach out to us if you have any questions into this solution, Prometheus multi-tenant proxy. And this is our open source project. Feel free to try it out. Let us know if you have any questions. Thank you, everyone.
Thank you for today's session. So demo part is very good. So I would like to understand few more bit over here. So if I'm using multi-instance GPU, so is it possible to get the metrics at namespace isolation level using Prometheus proxy?
Yes, it is possible. So we have another concept called prom-label-proxy. Are you aware of it? Okay, so what prom-label-proxy will do is, it will check the namespace label filtration.
Not able to hear you.
Okay. Yeah, we have a concept called prom-label-proxy. Are you aware of prom-label-proxy?
No.
Okay, so what prom-label-proxy will do is, it will do the filtration so that the namespace that is generated from that metrics level, right, it has to match from the originator namespace. So that kind of filtering it will do. Based on that, you will get the metrics even if you run multi-GPUs at your namespace level. Yes, it is possible to get those metrics.
For that, I need to use single data source, or I can create multiple data sources?
Single data source is sufficient.
Okay.
Yeah.
Thanks.
Yeah, hello. The one question I'm actually here is like, we can also use Grafana Mirmir, which actually use the same thing.
Sorry, could you come back again? Grafana?
Grafana Mirmir. Mimir.
Grafana.
Grafana memory or?
Mirmir.
Because this is focused mainly on the multi-tenant isolation, so tenant-based isolation, right?
Yeah, so the thing which I'm also looking around is like if we can send the data across, because what it actually does is like Prometheus can send, all different Prometheus can send data to a centralized repo. And from there you can actually create your dashboards and also filter out the data. So this specific Mirmir Grafana Mirmir can do that. Like if you can integrate with Prometheus and just send the data to Mirmir, then it will be
External impact.
Okay, so I don't think multi-tenant isolation possible at Grafana level. You have to do that multi-tenant isolation at cluster level. Then those metrics can be shifted to the Grafana, and it will act as a from data source, and it will show the data from the dashboard that you have built. You can think of like Grafana could be at something like Nginx proxy. Whatever the data sent to the Grafana, it just show there, rather than having the multi-tenant isolation at Grafana level. Yeah. I hope that answers your question.
Yeah.
Hello. Yeah, the demo was good. So I just want to know like how we can, the same setup, the configuration can be done for the Windows infrastructure. Is it the same easy in the similar way?
Is it for Windows?
For Windows Server.
Windows Server. Windows Server we haven't experimented it.
So, yeah, Windows, to be honest, we didn't experimented it. But I have a question to you. The Windows structure that you are using, it has Linux nodes, right?
Only Windows.
Then there will be Windows.
It is only Windows.
Oh, it is having only Windows. Yeah, we need to add support for that, because the one that we have discussed is mostly on Linux based. Yeah, we will take up the future requests around that one.
Mostly you will be exposing it as a Windows exporter, right? Windows exporter, through that you will be exposing the cluster level metrics. And again, we need to ensure that this has to be configured. So that was not yet kind of done as part of the POC in this.
Thank you, sir.
Okay. Yeah, thank you, everyone. This is the last session for us. I hope you all enjoy. Thank you.
Thank you all, and thanks to the program committee also.